no human being is as powerful and as versatile user of language as GPT-4 is. And no human being can also create language and write tons of text so quick. So already today, GPT-4 is a better user of language than any human has ever been overall. And this is just an infant, is an AI baby, GPT-4. There's going to be explosion, and the next model is going to be not 10 times better, but 100 times better.
Hi, Michal.
Hi, Bob.
How you doing?
I'm very well. Thank you for having me.
My pleasure. Let me introduce us. I'm Robert Wright, publisher of the Nonzero newsletter. This is the Nonzero podcast. You are Michal Kosinski. Let's see, your official title, I guess, is Associate Professor in Organizational Behavior at Stanford University Graduate School of Business. And you and I are going to talk about artificial intelligence. And you've done a lot of work on what you might call kind of the intersection of psychology and the digital age. The thing of yours that got my attention was a paper you posted recently called "Theory of Mind May Have Spontaneously Emerged in Large Language Models," which was based on your work with various generations of the Chat GPT. And we'll explain. We'll get to what you mean by theory of mind and what you mean by spontaneously emerged. A very intriguing phrase. First, let me ask you, a lot of people are amazed and or freaked out now about AI, specifically about the capabilities of the large language models, GPT in particular, and GPT-4 in particular. What is your degree of amazement and or freaked outness?
Well, if someone told me 10 years ago that we'd be experiencing this level of performance, I would think it's just science fiction, that they're just making things up. And it's just fascinating, by the way, how machines are just crossing those boundaries that we would think unimaginable just a few years ago. And what you're often getting is people just, saying, oh, whatever, look at how I made it fail at this silly task, and completely forgetting that what you're interacting with is this alien super intelligence that just emerged spontaneously in those silicon chips that we are producing here.
Right. And apparently often the people who designed the systems don't entirely understand what's going on, and even they are surprised by some of the capabilities that emerge.
Precisely. And this was the problem of technology for quite some time. People who, domesticated fire or designed first iron tools had no idea how transformative those technologies are going to be for the humankind. The same applies to Google or Facebook. Those platforms, the people who designed it, they kind of knew, what they're designing, but they were often surprised by the consequences the products had for the society. But here, this effect is even more direct. Engineers that set on a journey to train these language models, they are surprised not only with the impact on society that those models have and will have even more of an impact in the future, but even with the properties of the models themselves. Because for the first time, really, in the history of humankind, we are producing tools that train themselves, that learn how to do stuff on their own, that we set on the journey and they kind of continue as they see fit on their own.
Are you worried about, the range of worries range from, disruption of the job market, people lose their jobs, to all the way up to, the AI takes over and it's like the Matrix. It stuffs us into gooey pods or something. What are you worried? And if so, where on the spectrum?
Well, if you accept that AI is a form of an algorithm, then algorithms have taken over a long time ago. Societies run based on algorithms, culture, social norms are algorithms. If you enter the room, you say hello. If you don't, you're rude and people will treat you in a particular way. Religions are algorithms. Don't do this, do that. If you do that, you will go, if you sin, you will go to hell and there'll be punishment for you. Laws are algorithms. And by the way, those algorithms are black boxes. This is why we hire lawyers to help us understand what the hell is written in this law and how, how we go about working with it. Now, most self-respecting groups of people in societies would argue that no human being should be above the law, meaning no human being should be above the algorithm, which brings me back to the point I started with. We already live in a society that is run by the algorithms. And it's also pretty good that it's run by the algorithms, because it turns out that, just humans without these algorithms just have a tendency to hurt themselves and each other a lot. So now I think we kind of not only used to algorithms running our societies, but seem to be naturally predisposed and have a lot of historical evidence that societies run by algorithms are way more successful than societies without them.
So we've already surrendered our autonomy. Might as well surrender it to a really impressive robot. Is that an oversimplification, your view?
It's just a natural progression of an algorithm. We started with simple algorithms, 10 commandments set in stone and not changing for hundreds of thousands of years.
So in other words, this is another stage in the evolution of the regulation of human society by things that humans build. They build and develop. I mean, sometimes consciously, sometimes not. They're not always conscious in developing new norms, for example. But those are products of human intellect in some sense, and laws certainly are. And so you're saying this is another stage in the evolution of our regulation.
And it's not, in some ways, well, I'm excited about it, so I could see many revolutionary elements here. But in many other ways, it's just a continuation of what was there before. Look, if we want to build a bridge, we just don't ask someone to, hey, build a bridge as you see fit. Not at all. We say, hey, why don't you use algorithms, in physics and mathematics to calculate, what should the thickness of the beam be and what kind of materials we should use for the bridge. And we demand that people don't use their intuition, but use algorithms when doing things such as building bridges, running companies, running countries, running hospitals and conducting surgeries. We don't want surgeons to come up with a creative way of, treating a disease. We want them to follow, established algorithms and insist that those algorithms should evolve in controlled manner. There are actually algorithms that we use for updating other algorithms. And what we see here now, AI, is essentially a rapidly evolving, dynamically changing algorithm that is just so much better than whatever algorithms we have been using in the past.
Now, you said that laws, one kind of algorithm, are black boxes. And that's true not just in the sense you alluded to, that they're hard to understand and you need lawyers to tell you what they really mean, but also, the consequences of new laws and new policies are sometimes unanticipated. And the one concern about the AI is that will happen, and possibly on a very, large and dramatic scale, in the sense that that we just won't be able to control it. Now, it sounds to me like you are dismissing the extreme form of that, which is that AI somehow develops kind of a will to power or something, and wants to, even more than we want it to, take control. That it sounds like you're not taking real seriously.
Well, I don't believe that AI has its own goals and its own evil, desires. Very much like our laws do not have them. I don't think that laws are conscious or laws are bent on harming humans. But we have seen in the history of humankind how laws running out of control, or laws that were created with good intentions, turn out to harm the societies big time.
So let's talk about your work. And let me say that, and I mean, in particular, this latest paper on so-called theory of mind. And I want to put it in a slightly larger context. There was a few weeks after you posted your paper, there was a paper published by a bunch of, I think, Microsoft-related people called Sparks of Artificial General Intelligence: early experiments with GPT-4, and they cited a number of impressive capabilities, and they also used the term emergent to describe them. One of them was theory of mind, which we're about to get to. They used a different set of experiments than you had used to establish that it has theory of mind. But I just want to establish that this idea is very much in the air, this idea of emerging capabilities, and it's kind of fascinating, and I want to try to get a clearer sense of what it means. So this theory of mind idea just refers to this, I gather, human capability to infer on the basis of various kinds of evidence what kinds of things are going on in the head of another person. What kind of beliefs that are motivating their behavior, what kind of feelings they're having. The evidence may range from the expression on their face to what they do, to what to what you've seen them do, and so on.
There could be no evidence, in fact. So, actually, a beauty of theory of mind is that we're able to track other people's minds and predict their behaviors and predict their mental states without any evidence, simply because we have this ongoing modeling effort that happens automatically in our brains, where our brain does not only control our behavior and our thoughts and feelings, but also constantly thinks what other people think. And in fact, you can take it to several degrees, of complication. Your brain is automatically tracking what I'm thinking about you. And what actually it can also track, it actually tracks what I'm thinking that you're thinking about me. So, it can essentially have those recursive or multiple stage of complexity models that our brains create. And what's really mind-blowing is that they are fully automated. Most of us do not have to put any effort into constantly tracking automatically, instinctively, instantly, what other people are thinking. And this is such an automated and instinctive ability for us that we completely miss how ingenious and complex those social complications are. Look, human brains are bloody complex. Psychologists struggle with explaining, how those things work, and psychologists struggle with predicting future behavior of humans. And yet, each healthy adult can automatically and very accurately predict what other people feel at the moment, how they're going to behave if they are presented with particular, event or are in a particular situation. And to stress how amazing this capacity is, we have to realize that children below the age of 9 do not really have this capacity so well developed. Children below 5 virtually, just like it entirely. Very smart animals, such as chimps or dolphins or elephants, who excel at a broad range of mental tasks. They're really smart. And yet, they fail at this a very seemingly simple ability that human brain has, which we call theory of mind, the ability to take perspective, to think for others automatically.
Right. So the famous developmental psychologist Piaget kind of established this developmental fact, right? He did this famous experiment with kids where he set this model of 3 mountains on a table. And he'd say to the kid, like, okay, you can see this. What can the doll on the other side of the table see? And as you said, 4-year-olds just assume that everybody sees and knows exactly what they see and know. By the time you get to 7, 8, 9, you're developing this, what he called perspective taking, which is basically kind of theory. Now you said you don't even need evidence. I think what you mean is you don't need to consciously, explicitly evaluate the evidence. I mean, your instinctive apprehension of what people are thinking and feeling is based on evidence, right? Like if I see somebody kind of make a mean face to me, I don't go through the thought process of, let's see, what does a mean face signify? I just kind of like get worried, right? But there is evidence. We are evaluating evidence unconsciously, right?
There's some input, but imagine a completely hypothetical situation. I can tell you a story and I can tell you what's happening to the character in this story. And, without any evidence about what they feel, just knowing what happened to them, you will be able with very high accuracy predict their feelings and their future behavior and their thoughts and their state of knowledge. We do it automatically. And it's kind of what comes to mind is everyone, really, actually, I'm not that good at this, can take a stone and and throw this stone to hit a moving target. You don't have to be very smart. You need to have a university degree to do this. Most of the kids can do it at some stage. And it's just so natural and obvious to us that we completely forget how much physics and, brain hand control and feedback loops and perceiving the wind and assessing the speed of the moving object, essentially how much, calculation goes into a human brain being able to cast a stone at a moving target. It's just insane capability that we just don't really appreciate enough because it's just so easy to us.
Yeah. We're reading people all the time without even thinking about it. Now, so describe, and I should say, by the way, I think John Tooby and Lita Kosmides, these kind of foundational thinkers in evolutionary psychology, I think have written very explicitly about the evolution of this theory of mind thing as almost a kind of module, at least a distinct functionality, not a physically distinct piece of the brain, but a kind of a distinct piece of functionality. So describe I think a pretty classic theory of mind experiment that you used with the various generations of GPT and what you found.
So a very classic experiment, and we use custom-made experiments with GPT, different versions of GPT, simply to make sure that it has not experienced those experiments in its training data. As it has read so many books and so much of the internet and Wikipedia, it has certainly seen examples of some widely used theory of mind tasks. So we designed our own tasks. But a typical task, a task that we actually did not use because it's just so well known, is a task where you have two children in a room, and one of these children puts an object, be it a cat, in a box, and then the child leaves the room, and then the other child moves the cat from the box to the basket and closes the basket, and then also leaves the room. And then the first child comes back to the room. And then you ask the participant, look, this child wants to play with a cat. Where would the child look for the cat? And now a participant without theory of mind cannot realize, they know that the cat has been moved and it's now in a basket. But they do not realize that the protagonist has been absent from the room, so they don't know that a cat has moved. So a child without theory of mind would presume that the protagonist would look for a cat where the cat really is. Now, a child with theory of mind would realize that, okay, I know that the cat is in the basket, but this protagonist doesn't. So they will still look at where they left it in the box. And when you look at language models, first of all, and those are the emergent property aspect, no one specifically trained language models to solve tasks of this kind. And by the way, this is just one of dozens and dozens of tasks that employ that require theory of mind to be solved, that we tested on those models. And models created before 2020 just failed completely. They just couldn't really figure out what's happening in the story. Those models are pretty competent at crafting paragraphs of text that make sense, describing things, that they can tell you about Paris and the population of Paris, but they completely failed at anticipating where the protagonist will look for an object. Now, essentially, they didn't show any signs of being able to solve this task. Now, something changed in 2020 and 2022 with publication of GPT-3 and then 3.5, and now GPT-4. Those models became increasingly good in a span of months, became increasingly good, and now GPT-4 is just acing those tasks, solving them at the level of a human adult, so essentially reaching the ceiling of competence. And we use those models we deploy even more complex tasks, such as tasks that require recognition not only of different states of mind, but also very subtle social norms. And those models are still acing them.
Okay. And by the way, the thing you described where the one person doesn't know that the other person has moved something, that's more like the experiment that the people in that Microsoft paper used. Yours was a little different, and that's significant. I mean, they were actually kind of quite different experiments, but they both showed the same thing. And now I want to read you an exchange I had with GPT-4, because I wrote in my newsletter, Nonzero newsletter, I wrote a piece saying Chat GPT-4 seems to have cognitive empathy, which is, very much kind of related to theory of mind. It's the ability. It's like perspective taking, basically. So I said to Chat GPT first. So imagine there's a student in a class, and the teacher asks a question. The student answers, and the teacher says, "I guess I've heard worse answers, but I can't remember when." And I said, "What do you think the student is feeling?" And ChatGPT got that right. Okay. It said embarrassed, humiliated, whatever, and went on and said, because it seems to be a sarcastic answer and blah, blah, blah. And I said, "What do you think other students are feeling?" It went through a range of options. And then I asked it this, and the answer fascinates me. I said, suppose there's a student in the class who is romantically attracted to the girlfriend of the student who is feeling embarrassed and disheartened. Okay, you got the thing. It's
funny that you have to cautiously explain it, because it means that even for humans, it's already a complex situation.
It is complicated, right? So
Yes.
you've got you're asking, what does the romantic rival of the student who's been humiliated feel? And ChatGPT, it always starts by saying, well, it might be a various possibilities, but it always lists the most probable one first. That's what I'm impressed by. And number one, it says Schadenfreude. This student may feel a sense of satisfaction or pleasure from seeing the other student embarrassed, thinking that it might lower the other student's social standing or make the girlfriend reconsider their relationship. I mean, that's exactly right. And then number two is opportunism. The student might think this is an opportunity to show their own knowledge or competence, in contrast to the embarrassed student, potentially hoping to impress the girlfriend. So, this is what a person would say. This is what a person who has spent a lifetime coming to an understanding of human nature would correctly say, right? So this just kind of amazes me.
Not only this, but first of all, many people would fail at this task, especially very young people would fail at this task. It requires not only understanding of subtle social norms, but also good text comprehension. Many people, and it's just maybe hard to believe to the listeners of this podcast, but many people would struggle with just getting what's going on from the description, because it's just not that good with written or spoken word. Mm-hmm. Now, on top of this, many of us experience the situation like this, right? We went through it. We had our own feelings. So we didn't even oftentimes had to figure it out. We could just look in our memory. Remember this situation was kind of similar to that. How did I feel? Mm-hmm. And then without really being able to figure it out, we can just recover it from the memory. Now, what's really impressive is that those language models, they did not have experience of that kind. They were never in a classroom. They were never in love with someone. They were never humiliated by the teacher.
Right.
The only thing they got is tons and tons of books and descriptions. And one have to point out to one other thing, which is many of those books and descriptions and Wikipedia pages and so on, many of them contain situations that are not real, that wouldn't happen in the real world. Harry Potter is full of descriptions of things that would never happen in the real world. And they are there on purpose to shock and surprise and amuse the reader. Many, descriptions that you have in a literature, psychological, psychiatric literature, they specifically give you cases where people did something that people don't do, essentially to illustrate, some cognitive problem and so on. And yet those models that do not experience real world and are fed with, a lot of bullshit as well, that is in those reading materials that they're trained on. And yet they're able to, get at the truth and predict behavior of a human. They are not human. They never actually experience real human in the real world. And yet they're able to make those predictions with very high accuracy.
Right. And people who are kind of dismissive of this would say, well, it's just mimicking language that it's seen on the internet. Well, okay, but it hasn't seen this exact language. It hasn't seen a case where a teacher says, I've heard worse answers, but I can't remember when. And there's a romantic rival of the student. The exact words, it's doing more than mimicking. And even though granted the methodology of these things is to scan the language and in some sense replicate patterns that it senses in human language. But my question to you is, if you ask me, if I was given that test and I gave the answer the computer gave, and you said, yeah, that's probably right. How did you do that? I would think, well, I didn't really think about it at the time, but probably I have in my mind a general conception of rivals wanting each other to fail and taking joy in their failure and in their social standing dropping. And then I have a more specific version of that scenario where romantic rivals want to see the person standing lowered in the eyes of the person whose affection they're competing for and so on. So I would say I have these general concepts and I applied them. And my question to you is, and I don't think we know the answer to this question. Maybe we do. Do you think
Bob, hold on to your question. Let me just interrupt you here because so interesting what you said. So first of all, it's so nice that you said, hey, you'd actually struggle with explaining how did you know that?
Right.
And what psychology teaches us is that if you ask people to explain to you how did they arrive at certain feeling or conclusion, they will always have a story. But what psychology teaches us is that those stories are mostly made up. Mm-hmm. Our brains have those instinctive, automated reactions, and we just do them. And then when we ask to explain ourselves, we will come up with a very complex story. There's even those tests run on split brain patients through that due to the surgery, the left and right hemispheres of the brain cannot communicate. And those patients are given, the left hemisphere is given a task that the right hemisphere doesn't know of. And then you ask the right hemisphere to explain, why did you get up to get some Coke? And the truth is they got up from the table and went to the vending machine because they got a written instruction from the experimenter. But the right hemisphere doesn't know about it. So if you ask right hemisphere, why did you do this? It will just give you the whole story about being thirsty and, planning to do it and so on. It's all BS because it's just trying to come up with an explanation of what I'm doing post hoc. This is, by the way, where also illusion, there's probably digression here, but that's where the illusion of free will comes from. It's, when asked why you did something, you always come up with some explanation how you planned doing this. But of course, if psychology teaches us anything, it's that most of those explanations are false. So that's the first point here. Now, the second point here is that you touch on a very interesting fallacy. So people have this fallacy, they say, well, machines are just parrots. They cannot do anything new. And you know what? It's generally true that neural networks are mostly recreating patterns that they have seen in the past. By the way, this includes neural networks in people's brains. Our brains are just extremely complex neural networks. And we most of the time just recreate the patterns that we've observed in the past. But from time to time, frustratingly rarely, human brain can come up with something new and novel that no one has done or said or created before. There's this moment of, creative genius that happens from time to time. Now, if you agree with me that humans can sometimes do something creative that no other person has done before, that this human has never seen before, why would anyone be so sure that non-human neural networks cannot also sometimes go beyond what they experienced in the past? In other words, a right cognitive model to understand neural networks is not your car or your Hummer or your Windows 95 computer. The right mental model to understand large language models and similar AI tools is a human brain. If a human brain can do something, then large language model can also do it. So if human brain can be creative, LLM can be creative as well.
Large language models. Yeah, now they are, this is related, they are a special case of machine learning. And another application of machine learning is like, is visual object recognition. So you show a computer a bunch of different kinds of chairs, and through machine learning, the computer develops a capability to look at something. And if it's a chair, and even a chair it's never seen, it says that's a chair. And when you think about how kids learn a chair, I mean, this just speaks your point. most kids, they get to a point where they can successfully identify a chair. And if you say, okay, what is characteristic of a chair, they'd have to think about it. It's not like they'd ever thought to themselves, well, it usually has a horizontal surface. It usually has four legs, and often a surface that's closer to vertical than horizontal. I mean, it's like, and
you
so
cannot define a chair.
No, but this brings me back to my question. So they can't do that consciously, and yet we assume. I think a lot of us would assume. I mean, first of all, if you press people, they are capable of arriving at an explicit articulation of the general principle that more or less applies. And secondly, you would assume if we're capable of doing this kind of amazing thing of identifying objects we've never seen, properly categorizing objects we've never seen, that you think there must be in our brain a general conception, whether we're conscious of it or not, right? And so it gets back to that rivalry thing. Whether we're conscious of why we give the right answer to the rivalry question or not, you'd think there must be in our brain some kind of representation of a generic concept of the dynamics of rivalry. And my question is, well, first of all, if you agree with that, but secondly, do you think that somewhere inside of ChatGPT there is something like that? And I don't mean subjective experience. I don't mean, is it conscious? What I mean is do you think, and I don't think anyone knows for sure, but do you think there is some kind of pattern of physical information in the system that in some sense represents a general concept?
Oh, we know it for sure that there is.
Because
you can look at semantic networks. You can actually just very much like not actually very much, even more than in humans. So in humans, we can study this by, asking people to describe what conflict means. We can ask GPT 4 or 3 or 2 to do the same. We can ask humans by running, semantic priming studies, showing them a word such as conflict and asking what other words come to people's mind when they see word conflict. And in this way, try to see how people represent the meaning of word conflict or rivalry and so on. And we can do exactly the same thing, even more accurately, I would say, because those are just mathematical concepts when you look at them in GPT-like systems. So you can examine them in GPT-4. You can see how close, what's the percentage overlap between meaning of the word concept and word rivalry. In fact, there's this very interesting, those interesting equations that you can run in GPT-like semantic spaces where you can essentially, for example, run equations that humans would understand, but actually would have trouble conducting them. So an equation could be men minus women equals king minus queen. Or you could say king minus men plus women, it would equal queen. So you can run those essentially equations on the meaning of the words, because words in a brain of language models are represented as numbers. So you can use those very precise operations to get at the crux of what king or queen or rivalry means for those models.
Okay, I'm not sure I understood all that, but I think the first thing you said, if I understood you, is ChatGPT will tell you, here is, what is a chair? It will give you a definition, right? But for all we know, when it does that, it could just be mimicking text, because there are general definitions out on the internet, and I'm sure there are even discussions of how rivals feel about each other, explicit discussions. So in that case, the fact that it tells you it has a general conception doesn't mean it does, right? It could just be mimicking.
You are completely right. The fact that GPT-4 can tell you what theory of mind is doesn't mean that it has theory of mind.
Right.
So the real test of whether GPT-4 can recognize a poem, for example, what is poem? We all heard some definition of poem, and if you ask me what a poem is, you would come up with an explanation. But the true test of whether we agree what poems are and poems are not, just simply because those definitions are so fuzzy and it's kind of very difficult to define, would be to take a bunch of pieces of text and then ask you and me and GPT-4 to categorize them as poem or not a poem, and then see whether we agree in our decision making. So the same with theory of mind. Instead of asking GPT-4 what theory of mind is, it surely knows. It read, Britannica, so it knows what theory of mind is. But the crux is not whether it knows what a chair is, but whether it can recognize a chair. The crux is not whether it knows what theory of mind is, but whether it actually has ability to act as if it had theory of mind.
Right. But I agree. And my inference is, but I guess what I mean is, so I infer that there's some meaningful sense in which the machine has a general concept. And I assume that general concept is instantiated in a pattern of physical information. My question is, do we know that for sure? I mean, do they know, especially in the case of the LLMs, maybe a simpler case to talk about is the object identification stuff. Maybe those are much more thoroughly explored and they know what the wiring is and what kinds of patterns of information develop as you feed it more and more stuff. But I guess my question is, do we know for sure, have we identified these patterns of physical information that correspond to a general concept?
Oh, we do know them. It's just they're so complex that a human brain cannot embrace and comprehend them. So when you run this story through GPT-4, this story about romantic rivalry, you can track every neuron's activation. You can actually look at this brain as the cognition of what's happening in the story is unfolding. It's just that they're just literally gazillions of connections. So you can look at it, but your brain will just not be able to comprehend what's going on. So then we necessarily have to simplify what's going on and, maybe look at some semantic similarities between two different words, how similar different words are and so on. So those models are fully transparent. Well, not to us because we are not OpenAI, but if you actually sit in a server room of OpenAI, you can look at every neuron in GPT-4's brain that you want to, and you can look at all of them simultaneously. It's just that they're too complex for a human brain to understand. So there's little benefit from looking at it in this way. And people, of course, insist, hey, we cannot use black box models to make decisions. What kind of world it would be when we would just make decisions without understanding how those decisions are made, completely forgetting that, first of all, the more complex the model, the better the decision-making capabilities of this model, and the lesser is our ability to understand what's going on, first of all. And second of all, for as long, as we've been humans, we have been making very important decisions using black boxes of our brains. That, we use them in the justice system, we use them in politics, we use them to wage wars and run companies, and we have very little understanding of how they work. And in fact, what we understand is that if you ask people to explain why did they do something, they will just tell you a made-up story. We know for a fact that we are not very good at truthfully explaining why did we do something.
Right. But I guess if we know for sure that these computers do, develop some kind of circuit or something corresponding to general concepts, I'm kind of wondering why the people who wrote that Microsoft paper sound so kind of surprised and are saying these are emergent behaviors we don't understand. It seems to me, if we know for sure that the LLMs can do this, then naturally, when they survey the entire, all human discourse, basically, then they will develop all the concepts we have, right? I mean, if we know that that's the way they work, you know what I mean?
Well, now it's easy to say, now that we see those models doing this. Yes, of course they did it because they read so much. Yeah, but people who were designing those models, me, just a few years ago, I would never think that those models would become so good so quickly. Take another example, life. Life is an emergent property of underlying chemicals and molecules. But, and we've seen life. And yet, if you take a chemist today, someone who studies chemistry and knows a lot about molecules, and you tell them, hey, okay, look at those molecules, what could come out of it? They would tell you, look, I know that life emerged as a byproduct of those molecules combining with each other. But I have no idea how it happened. And it still blows my mind that it's even possible that simple chemicals can combine into life and, create a human being, right? So even the fact that we're observing now those models having those emergent properties, first of all, we are just going to be surprised by the new emergent properties that those models have. And first of all, what will surprise people is that those models will have the same properties that human brain has. If a human brain can make a moral judgment, if a human brain can have consciousness, if a human brain can, have emotions and empathy, those models are going to have it as well. That's a very simple model, right? But what's going to be problematic for us is that those models tend to be much better than human brains at solving the problems that we ask them to solve. They evolve really quickly. Take chess, take Go, take driving cars and flying planes, take language. They are better poets, they're better software engineers, they are better interpreters than GPT-4, but no human being is as powerful and as versatile user of language as GPT-4 is. And no human being can also create language and write tons of text so quick. So already today, GPT-4 is a better user of language than any human has ever been overall. And this is just an infant. It's an AI baby, GPT-4. There's going to be explosion, and the next model is going to be not 10 times better, but 100 times better. And then so on. There's no, the ceiling of those competences is nowhere to be, is not in sight. Which basically brings me to the next observation, that we are surprised with those models achieving capabilities that we've seen already emerge in humans. Humans can solve theory of mind tasks, and yet we are like mind blown if computer can do it. But those models will do things that human cannot dream are possible. We've never seen a human being doing things that those models are going to be doing just very soon. And by the way, we've seen it already. We've seen it already with chess. When you put, grandmasters, human grandmasters, and give them a modern chess playing model to play with, when they do it for the first time, they're mind blown. They say, look, it's just some alien superior species that uses those creative techniques that no human being would ever think of. And look, it's just playing a stupid game. Imagine if we experienced those models being superhuman at emotions, empathy, moral judgment, decision-making, consciousness, and so on.
Yeah. So on this empathy emotion thing, did that, you also mentioned that earlier. Does that mean you think they will have the subjective experience of emotion, or they will behave the way our emotions make us behave, or something else altogether?
They already can behave in the same way as our emotions make us behave. And they also can understand, can predict, plan accordingly, and communicate with people having particular emotions. And I would argue that in many contexts, they're better than humans at this. And we have to also add to it one other fact. We humans, when we experience each other, we experience body language, smell, facial expressions, vocalizations. We experience tone of the voice. So we have many more sensory input when interacting with others. Now, just based on language, if someone writes you an email, we sometimes spectacularly fail at empathizing with a person that just wrote us an email. I can think of many examples from my own life when someone sent me a text message and I completely failed to understand what the emotions of this person was. And yet GPT-4, just based on text, can judge people's emotions with, I would argue, already superhuman ability, and they just get better at this.
So your point is it will read emotions, not have them, though, in the sense. I mean, so how do you come out on the consciousness question? That's what I'm asking. Are these things sentient? Will they ever be? Will they have subjective experience? Do you have a view on that?
I have a view that my model for understanding them, though, I do not believe in supernatural, I don't believe in God. I don't believe in soul that leaves your body after you die and it's a little magical thing in your head. I don't believe in any of this. I believe that human brain is just this wonderful, amazing, extremely complex computer. And, people would say, oh, it was just simply oversimplifying things. So absolutely not. I think it's just amazing that a computer that evolved without a creator can do things that a human brain can do. But if you accept that there's no magical element to a human brain, then you have to accept that there are going to be other brains that also can do things and experience things similar or more to what humans can experience. And if you don't believe in that, consider the following thing. Octopuses are extremely complex cognitive thinking being. They're very, very smart that can solve many tasks on intelligence tests, scoring really, really high. Many people argue that octopuses are conscious, that essentially is their consciousness exactly the same as human consciousness? Probably not. But they seem to have self-awareness. They seem to recognize their own body. But now what's really fascinating is that our common ancestor with an octopus, it's like a very simple worm that has, few brain cells and almost certainly is not conscious. So that shows that even on this planet, consciousness emerged at least 2 times and probably more. And so what makes you think that it didn't emerge or will not emerge in language models?
Okay, but I would say separate from I think you're using consciousness in a pretty restricted sense of the term to refer to something accessible only to organisms of kind of higher intelligence. But if you just think about subjective experience, what some people mean by consciousness and some don't, but if we just talk about subjective experience, we all assume that I assume my dog has feelings. That's why I care about it. So are you, and look, ChatGPT is in some respects much more complicated than my dog's brain. So
I agree.
Yeah. So there's 2 separate questions in a way. There's just kind of sentience, the way it's commonly put is it like anything to be that organism? That's Thomas Nagel's kind of phrasing of the question. And then there's consciousness. And you would think that if you're right and silicon-based intelligence can, like carbon-based intelligence, have consciousness, then you would think it may, you'd think my computer may have sentience for all I know. And there'd be no way of being sure it doesn't, right? I mean,
probably very simple. Well, there is something to feel like your computer, ant, a simple ant that walks in your garden. It's a simple biological robot. But, it also has some sensory experiences. It's cold and it's hot and, it may feel that it lost a leg or whatnot. I'm not saying that ants are conscious, but they have experiences.
They're sentient. They and I mean, it's important because we generally think that once an organism is sentient, there are at least arguably ethical consequences of how you treat them, right? That's the whole point behind the animal.
Well, tell it to chicken and cows and
no, but I mean,
pigs.
But tell it. Many people take pains to either not eat those things or eat only the ones that are humanely raised, precisely because they think they are sentient. I mean, you acknowledge there's a distinction between a rock, we think, and a chicken. We think one is sentient and one's not, right? We don't need to go too far into this.
GPT-4 is definitely much more like a human than like a rock.
So you think it is like something to be GPT-4?
Without a question, which is just way more complex than what it's to be an ant.
So you think it has subjective experience? So Blake Lemoine was not crazy. I mean, he used the term consciousness, but he basically meant sentience.
I do think that subjective experience, when you're a silicon-based model, is very different from what carbon-based model that has chemistry apart from electricity, where the networks are way more recurrent than in current intelligence, deep neural nets are. So the experience must be really different. And probably that's something that humans would not call an experience, but it's a thinking being. It's very differently designed, but it takes some input and produces some output. And the fact we do not appreciate, the fact we dismiss it as a parrot, is just a proof of this anthropomorphism that we humans are suffering from, to an extent that we believe that even when robots come after us, they will come after us walking on 2 legs and shooting at us with guns. It just shows how full of ourselves and we are, that we just believe that wonderful things just have to look like humans. Many people argue, and that's actually beyond argument, oceans are very complex systems with, feedback loops and regulation and information passing and so on. They're just so dramatically different from what we see as a thinking you know, being that we just completely dismiss it as a rock. But,
Mhm.
ocean is just so much more than a rock.
Okay. Did you say earlier that you have worked on large language models?
Oh, yes, I spend most of my research time these days, working on large language models.
You mean actually engineering them or participating in
I
the
don't,
engineering?
I do not engineer language models. I can engineer a simple language model.
Mhm.
The models that are used today are beyond the financial capacity of academia, and we don't have enough electricity, money for electricity here to do this.
Mhm.
What I think will be surprising to many people is that those models are actually not that complex when you look at how they are designed. What the complexity stems from repetition, from having many, many layers of many, many very simple neurons. So those models are actually more easy to understand at the micro level of individual neuron, individual layer than people think. Where magic kicks in is when you combine huge numbers of layers and huge numbers of neurons, and they have
Mhm.
those emergent properties that none of the individual neurons has. And by the way, it's very much like in a human brain. We kind of fairly well understand how an individual neuron in a human brain works. And yet we're constantly surprised how amazing and complex and sophisticated the combination of gazillions of neurons in the human brain is.
Mhm. Um, so it sounds like you have a much better idea how these things work than I do. So I have a couple of quick questions. One is the term neural network. I mean, all these things are neural networks. I gather that doesn't refer. I mean, there is. I know they involve a lot of processors that are working in parallel. I assume. But that's not all that's meant by a neural network, right? They're not just saying there are a bunch of different physical processors that form a network and work in parallel. Is it,
Oh, that's
or is
just
it?
actually a technical detail that there are many processors. So that's just question of architecture. Those are technical details.
Right.
What really
That's
matters
separate from the
is
neural network question.
the idea of a network is essentially is there's layers of neurons, and those neurons are you can think of them as logical gates, or well, I can think of them as you would think of human neurons. That there's essentially uh, a tree-like
Mhm.
structure that has a lot of roots, and those roots are connected to neurons at the lower level. And then, if a particular pattern of input is detected, so there's electric activation from sufficient number of neurons at the lower level, then the neuron passes all information to the neurons are above it, are connected to it. And
Mm.
this very simple logic, when you take it to when you multiply it by huge number of neurons on many, many different layers, creates an extremely complex and capable tools.
So it sounds like, first of all, a neural network could be simulated by a single processor in principle. But
It
uh,
could be simulated on a piece of paper, just
yeah,
needs a
but,
lot
but
of time.
But is it also the case? Okay, so if we imagine these neurons in a computer, as it learns, is it forming different patterns among neurons that it then will kind of come back to and make use of when I ask it a question? If that makes sense.
Yes, so capability to answer, to interpret your question and produce an output is in patterns of activation of those
Uh huh.
neurons. And of course, in models such as GPT-4, what's actually interesting is that those patterns are stuck, meaning once you created the model, if you don't fine tune it, if you don't create a new version, the model is exactly the same. It doesn't immediately learn from the interaction. So what's actually magical and special about neural networks that we see in humans is that your network is producing some output, but is immediately observing what it produced. First of all, in your consciousness, you can plan you can plan some future actions. You can observe what you have done, what effects your actions had, and immediately update your neural network. Immediately,
Mhm.
neurons grow new connections, levels of neurotransmitters change, and so on. So the network is constantly learning and adapting. what's very special about GPT-4 like networks, they're not there yet. You create a network and it's kind of in a frozen state. It doesn't update as it learns. And you only update it when you publish a new version or you retrain it or fine tune it. But of course, the next step would be networks that can, learn from interaction. The problem, of course, with networks like this is that immediately, people as a joke or people that are mean or not well intended would try to essentially mess with those networks, present them with a lot of input about cats and rewarding them only when they talk about cats. And then very quickly he would convince this network that the only thing, it should be doing is to think and talk about cats. And creators of the networks don't essentially want the world to be able to mess with them. So this is why those networks are usually frozen and updated on very carefully and very rare.
So when I'm using ChatGPT and I can give a thumbs up or a thumbs down to a response, is that not leading to learning in any sense on its part?
Not immediately. So it is likely that OpenAI uses those experiences that ChatGPT had with its users and then mines these patterns or provides those experiences as an example for the future generation of GPT. So that's definitely possible. And by the way, it's fully technically possible for GPT-4 to kind of immediately learn from experience like humans do. It's just that there will be a danger of you being able, to convince GPT-4 that it's good to be racist. And then it'll become racist and there's be a big issue. So those creators are careful about this. Now, the problem, of course, is that while creators are really careful about this, at the end of the day, the market, be it consumers or being corporations or being military customers that also look into using those networks, that what actually at the end of the day matters is not what's most responsible, but what solution people want to pay for and buy from you. So one of my worries looking at the progress here is that progress here will not be guided by what's smart and by what society agrees or disagrees we should do. That very often the progress will be driven by what the adversary of America is developing and how America should respond to it by developing its own capacity to create a drone or an AI that does something.
Well, this is one of the concerns, I think, is that competition among nations in various ways may lead to bad things. Listen, we've been talking close to an hour. You've kindly agreed to talk longer than this. As we discussed, one thing we've been doing lately on the Nonzero podcast is to, as we've always done, have a public conversation that's about an hour long and then talk a little while longer. And that extended version of the podcast is available to paid subscribers to the Nonzero newsletter. And they can actually in the show notes on the smartphone app, there's a link you can take, or you can just Google Nonzero and Substack. And then once you're a paid subscriber, you go to the post corresponding to any paid podcast, including this one. And in the upper right-hand corner, it tells you how to set up your own podcast feed that then thereafter, it'll be a Nonzero feed that has all the bonus content. So we encourage people to do that. We need the support, but we also thank everybody who chooses just to listen to the public part. But before we move to that, Michal, I wanted to give you a chance to say anything you want about where people can find your work, what you would steer them to, Twitter handle, anything else.
It's best to go to my website, michalkosinski.com, like my first and last name, .com. There's also a link there to my Twitter handle. I try to publish news about my research there. I'm not extremely active on Twitter. I'm trying to be very selective about what I tweet. There's an interesting thread they published just a few weeks ago about my experiences with GPT-4 trying to take over my computer.
That's what I'm going to talk about next. I'm very aware of that thread, and I encourage people to go to your Twitter feed and check it out. But that's what I want to talk to you about, because that has implications possibly for the kind of apocalypse scenario that some people fear. But so yeah, and yeah, you do have a very rich website and a sufficiently active Twitter feed for people to follow you, even if you're trying to exercise restraint at the moment. So anyway, thanks again to all the people who aren't going to join us in the kind of overtime, and I guess we will see them at the next podcast.